magnetic fields of loops and solenoids. In the previous section, we investigated the shape of a magnetic field created by a straight conductor. What would happen if we took this straight conductor and modified it into a loop, a circular loop? On the other hand, what would also happen if we were to place a lot of these loops in series? How would the magnetic fields of all these loops interact? These are the questions we shall delve into in this section. The magnetic field due to the current in a circular loop. What happens if you bend a wire into a circular loop? Let's apply the lesson we learned earlier. We can imagine the circular loop as being composed of several small sections of conductor all connected together roughly in a circle. If we take each of these sections individually and apply the right hand thumb rule to each of these sections, you will observe that the field lines are all circulating in the same direction. From the figure, you can see that these field lines are reinforcing each other because they all circulate in the same way. And in doing so, they are concentrating around the two faces or two openings of the coil, the front and the back. And as a result, this loop will now acquire a north-south pole orientation. The magnetic field of a current-carrying solenoid. As I said earlier, a solenoid can be seen as a collection of several loops all joined in series. Whenever you hear the word solenoid, just replace that word in your mind with a spring. What is a spring? A spring is simply a sequence of several loops of metal all joined together. Now, when you send a current through a solenoid, what you are in effect doing is sending the same current in the same direction through an entire series of circular loops. Each of these loops will develop its own north and south pole. And since all of these loops are joined in series, the north and south poles of all of these loops will reinforce each other. As a result, as you can see in the figure, the magnetic field inside the loop will become very strong and uniform as there are a large number of flux lines, field lines passing through that region. Also, if you insert a material like soft iron into this region, it will greatly increase the concentration of these field lines, and as a result, it will greatly increase the strength of the magnetic field. This is how you build an electromagnet.